Hey there, mathematicians. It's Miss Johnson, and today we are going to be finding a percent from word problems. Now, we already did a little bit of this at the beginning of the school year, but it's a real important concept, so we're going to do some more practice with it. Okay? All right, so let's just go ahead and look at number 1. It says the teams that won the coin toss won 7 of the first 42 WCAA championship games. What percentage of the time did the coin toss winners win the WCAA championship games? Okay, so what percentage, whenever you see that word, whenever it's asking you for what percent or what percentage, you always need to think in your head first, what fraction? What fraction of the time did the coin toss winners win? All right, so let's go back and look for when they won. Let's see what it tells us. Okay, so it says the teams that won the coin toss won 7 of the first 42. So the wins would be 7 out of what? 42. So remember, when we're doing a fraction, it's always what they're asking us for. So in this case, they're asking us for how many were won, and it's always out of the total. So it would be 7 over 42. 7 over 42. Okay, so you should always simplify. Always. Even though, these numbers probably aren't real hard, you still want to simplify. So we say 7 divided by 7 is 1, and 42 divided by 7 is 6. So 7 over 42 is equivalent to 1/6. So if I take that fraction and then I change it to a decimal and then I change it to a percent, it's going to be equivalent to 7 over 42. Okay? Now the way I teach my children to do fraction to a decimal is we do Nito. We put the numerator in and the denominator out. So numerator in, denominator out. That's Nito. So the numerator goes inside, the denominator goes outside, and then we put a decimal and a 0. And then we just divide. So 1, can't get a group of 6 out of 1. We get 1 group of 6 out of 10. Subtract, we get 4. Bring down the 0. 6 goes into 46 times. That's 36. 6 times 6 is 36. Subtract, we get 4 again. Bring down to 0. Got 40 again. And that goes 6 times. That's 36 again. And a little crazy with that line there. And then we're going to get 4 again. So do you notice what's happening? Yeah, it's repeating. So the 40 and the minus 36 is happening over and over and over again. So that means this is going to be 0.166666, and that 6 is going to go on forever. So that's our decimal value. Just going to put a bunch of 6s. Now, to make it a percent, you have to move our decimal 2 places to the right. I hope this is ringing some bells. So our decimal was here, and now it's going to be here. So our percent is going to be 16.6 repeating percent. Now, when you look at your answer choices, that answer is not there, is it? No, we have 16 2/3%, 7%, 29.4%, and 33 1/3%. Okay, so the answer is A. We can tell that because we've got the 16 here and we've got the 16 here. No other answer choices have the 16, so we know that is correct. If you didn't have memorized, which I want my kids to memorize, that 2/3 is 0.6 repeating. But if you don't have that memorized, what you could do to make sure is you could take the 2/3 and you could divide it and see if it equals 0.6 repeating. And it does. I'm just going to do it in a different color. So we're going to do Nito, numerator in, denominator out. And when you divide that, you will see that the 0.6 will repeat. Okay, so that's a way to check to make sure that you're getting the right answer. So 2/3 equals 0.6 repeating, which is what we have right there. So we could say it's 16 and 2/3%. Just for reasonableness sakes too as well, 7 is not a lot out of 42, right? So that means that we know that our percent is not going to be very big. None of these percents were very big, though, so it doesn't really help us eliminate anything, but still get it. Okay, so whenever they ask us for what percentage, we're always going to ask ourselves what fraction. We're going to formulate the fraction, then change the fraction to a decimal, and then to a percent. Okay? All right, let's look at number 2. Number 2 says, the best-selling book at Looky Books was Nightly Storms. Looky Books sold 480 copies in only one day. They had 320 copies that did not sell on the first day, or on that day. What percentage of the copies of Nightly Storm was sold that one day? Okay, so we're going to change percentage to what? What are we thinking in our head? To fraction. Good. So what fraction of the copies of Nightly Storm was sold at that one day? Okay, was sold. So not the ones that weren't sold, but were sold. So the ones that were sold was 480. Okay, so our fraction is going to be what was sold over the what? Over what was not sold or the total? Right, the total. Fractions are always the total number of pieces, right? So we know that 480 were sold, but do they tell us the total? No. What does the 320 tell us? The 320 are the copies that what? Did not sell. So what do you think we would do to get the total? Yeah, so the total will be the copies that they sold plus the copies that they didn't sell. 10 is 10, so 800. All right. Okay, so we should always simplify, and hopefully you see that we have zeros here at the end, right? So that means that we can divide both of those by 10, and 480 divided by 10 is 48, and 800 divided by 10 is 80. Okay, I look at 48 and 80, and I know I can simplify those by 8. And that's going to be 48 divided by 8 is 6. And 80 divided by 8 is 10. Can we simplify again? Yeah, I think by 2, right? Because they're both even, right? So if we simplify by 2, that will be 3/5. Okay, so our fraction is 3/5. And then I want to do what to that? I want to make it a decimal. So I'm going to do 3 divided by 5. Okay, so it's 0.6. And then to make 0.6 a decimal, it's already a decimal. To make it a percent, I have to move my decimal 2 places to the right. So that's 60%. 60%. Which that makes sense, right? Because it's reasonable is what I should say. Because what's half of 800? Let me do a different color. Yeah, 50%. So this is just estimate, right? Looking at reasonableness. So 50% of 800. Oh, Miss Johnson, write clearer. Okay, let me slow down. So 50% of 800 would be half 800, right? Which would be what? 400. Okay, so it's 60%, right? We said it was 60%. So 60% of 800 is 480. Is that reasonable? What do you think? Well, 60% is not that much more than 50%, right? It's just 10% more. And 480 is not that much more than 400. So it's reasonable. It's reasonable. It's okay. All right. So make it a fraction, and change the fraction to a decimal, and then to a percent. And let me just remind you of this too. This would just be another way that you could solve it. I was debating whether I should show you, but I'm going to show you. So we had 480, right, over 800. And we simplified it. Let's go down to 6/10. Okay. Remember, another way that you can get the percent is to make your denominator 100, because percents means per 100. So if you said 10 times 10 is 100, and 6 times 10 is 60, then 60 per 100 is 60%, making that fraction to a percent. Okay, so this is just another way that you could have done it, or the way you could have solved it. This works really well when you have a denominator that is a factor of 100. All right, number 3. Now, each one of these questions I picked because it's not just straight up, not all of them are just straight up. They give you the part, they give you the total, and then you can find the answer. Okay, a lot of these, there's another step that you have to do. Okay, all right, so Mary selected some students in her school at random and asked how they got to school each morning. Her results are shown in the table below. Okay, so ways to school: ride in a car, ride the bus, walk, 23, 51, and 18. So based on this information, what percentage of the students in the table above ride in a car to school each morning? So ride in a car. So they're asking us for the percentage. So we're going to think in our heads, instead of saying what percentage, we're going to say what fraction ride in the car. So we're going to do in car to what? That's right, car to total. So how many ride in the car? 23. And then what's our total? Yeah, they don't give us the total. So what do we have to do? Exactly, we have to add up these numbers. So we have to say 23 plus 51 plus 18. So 3 and 1 is 4, plus 8 is 12. And then 7, 8, 9, so 92. Ooh, this is going to be some dividing. All right, and so it's going to be 23 out of 92. It's going to be close to 23% because 92 is close to 100. Okay, so that probably means we can eliminate 51 and 55, right? Because it's got to be close to 23% because 92 is close to 100. All right, so let's divide it and see. I do not know a number that can go into 23 and 92. I'm going to be honest with you. So we're going to have to divide it. So do NITO, numerator in, denominator out. Okay, 92 can't go into 2, it can't go into 23. So add my decimal and add my 0. And then I look over here, because I do not know my 92 facts, right? What does my first number have to be? It either has to be a 2 or a what? A 5. Well, it's definitely not going to be 5 because 9 times 5 is 45, so it's going to be way too big. So I know my first number has to be a 2. So it's 4, and it's 18. I'm going to subtract. That's going to be 46. Add a 0, bring it down. And I know it's either going to, my next number is either going to be 3 or it's going to be what? 5. Okay, I'm guessing 5 because 2 times 5 is 10 and I have a 0 there. Okay, so I'm going to guess 5. If you need to, go to the side and multiply it. 4, 5, 46. Look at that, 460. Okay, so our decimal is 0.25. And then we move it 2 places. So our percent is 25%. B. All right, so on this one, they didn't give us the total, so we had to add to get the total. Okay, but our premise is still the same, right? We're still doing the fraction. We just had to add to get the total. All right, let's look at number 4. Oh, this one has a lot of words, doesn't it? Does that mean it's going to be hard? Nope, it just means we got to read, right? All right, so Sarah predicts that 15%, it's weird. I wonder why they wrote that word percent out. Let me fix that. So 15%. So 15% of all the birds she spots while bird watching will be robins. At the end of the day, she records 10 out of the 25 birds she spotted were robins. How does Sarah's prediction compare with the actual results? Okay, well, she predicted 15%, but they didn't give us the percent. They gave us 10 out of 25 were robins. So that means we need to take that information and do what to it? You have to be able to compare it, so we have to make it a percent. Okay, so her prediction was that there'll be robins. So they give us that she did 10 robins. So our fraction will be robins over total. So there were 10 robins, and did they give us the total? Yeah, she said it's 25 birds, right, out of the 25 birds. So if it wasn't the total, they would have had to say, and 25 birds that weren't robins, or 25 other birds. Okay. All right, so right here you have a decision. You can simplify. You can go ahead and divide it. You divide by 25, which is not real hard. Or you can make it equal to 100. You can say 25 times 4 is 100. So 10 times 4 is 40. So 40 per 100 is 40%. Okay, just to make sure, just to do both, that would be 2/5, right? You do neato, numerator in, denominator out. That'll be 0.4. And then move it. So it'll be 40%. So how does Sarah's prediction compare? So Sarah's prediction was that it would be 15%. But what actually happened was that it was 40%. So Sarah's prediction is too what? Yeah, it's too low. 15% compared to 40, it's smaller, right? So her prediction was too low. All right, let's look at number 5. Let's see how it's different. Okay, so it says, on 3 sections of the math test, a student correctly answered the number of questions shown in the table. Okay, so there's 3 sections. There's a number and operations, there's algebra, and there's geometry and measurement. The total number of questions, so there's 20 number and operations, 15 algebra, and 25 geometry. And then she got 17, right, correct for number and operations, 11 for algebra, and 20 right for geometry. What percent of the questions on the entire test did the student answer correctly? Okay, so we're changing percent to what? That's right, to fraction. So what fraction of the questions on the entire test did she get correctly? Okay, so what do you think we're going to have to do? How are we going to get the total that she got correct over the total for the whole test? Yeah, we have to add the sections, right? So she got 20, the total number of questions on the test were 20 number of operations, 15 algebra, and 25 geometry. So we have to add that together to get the total on the whole test. So 5 and 5 is 10, it's 4, 5, 6. So there were 60 questions. And then how many did she get correct? Yep, we got to add these up. So 8, 2, and 2 is 4. So she got 48 out of 60. Ooh, I do not want to have to do a 48 and 60. So I'm going to simplify. And I'm pretty sure we can divide by 12, right? So 12, 24, 36, 48. That's 4. And then 12, 24, 36, 48, 60. That's 5. So 4/5, you can either put it equal to 100 or you can just divide it and do neato. would be 0.8. So 0.8. Move your decimal 2 places to the right. So it would be 80%. Okay, so on this one, we had to do more math, right? Like we had to figure out how many she got correct, and we had to figure out what the total number of questions was. So sometimes it's not just as easy as just, oh, we just have to take the numbers that are there and make it a fraction, right? Sometimes we have to do something else in order to find the pieces that we need. Okay? All right, so look at number 6 and start thinking that way, okay? Is there something extra that we have to do to get this answer? I want you to pause the video and try to answer it yourself. Okay, so the chart shows the number of points each team earned on field day. Which team earned 33 1/3% of the total points? Oh my. Well, so we have to figure out which one of these is 33 1/3% of the total points. So that means we have to figure out the percent for each one of these to figure out which one is this. Okay, so our first step is to find the what? That's right, we have to find the total. So we got to add these up. 8 and 9 is 17, 18, 19, 20. So, carry my 2, 2 and 1 is 3. So 30 is the total number of points. All right, so let's just keep our work organized. I'm going to do blue over here. So blue is 8 out of 30. So I'm going to divide it by, I'm going to simplify it by 2. Yeah, because I can't go to 4. So 4/15. I'm going to divide it. So it's got to be a 3 first, right? For it to be the right answer. So 15 goes into 42 times. Okay, so I know that can't be it. I don't have to keep going because my first number needs to be a what? A 3, and my first number here is a what? A 2. So I don't need to keep going. All right, so let's do red. Okay, red was 10 out of 30. I'm going to divide by 10. I'm going to simplify it. That's going to give me 1/3. I do neato. Numerator in, denominator out. Okay, do we notice something happening here? Yeah, the same thing is happening over and over and over again. That's right. So that 0.3 is that 3 is repeating. Okay, so we're going to take and move our decimal point 2 places, and that's going to give us 33.3 repeating percent. So what do you think? Is it red? Yeah, it is red. Okay, if we wanted to check the rest, we could, right? Our yellow would be 9 out of 30. We can simplify by 3. That would be 3/10, and 3/10 is 3/10. Move it, which is 30%, which is not that. So it's not yellow. And then green would be 3 out of 30, which would be 1/10, which is 1/10, which is 10%. So it's not green. So our answer is red. Okay, so what was different about this one was that we not only did we have to find the total, but then we had to figure out the percent for each color. Okay, so that's what was different about this one. All right, last question. 3 eggs in the carton are cracked. What percent of the dozen are not cracked? What percent of the dozen are not cracked? Okay, so we know that a dozen is 12. If we didn't know that, we could look at our picture of the eggs, right? Okay, so if 3 are cracked, so 1, 2, 3 are cracked, how many are not cracked? Yeah, we would say 12 minus 3 is 9. And we could just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9 are not cracked. Because our fraction that we need is what are not cracked to the total. So 9 are not cracked, and our total is 12. And we can simplify by 3. And that will give us 3 to 4. And we do neato. It's 28. Subtract, we get 2. Bring down our 0. 5. So it's 0.75. And then we move it. And 75%. So 75% are not cracked. All right, so being able to find the percent is a super important concept for the grade that you're in right now. Okay, there's lots of questions that come from this. So I wanted to practice it with you. You need to keep practicing it. Okay, and so when they ask you for word percent, what's the first thing you say in your head? You change that word percent to a what? To fraction. What fraction? Okay. And then you make the fraction. Sometimes you have to add to get the total or do something else to get the total. And then you change the fraction to a decimal.